Hey guys, today we're working on completing the square, which is going to be a little bit confusing just because there's so many different ways that you can set it out and get to the same answer. If you've learned it a different way or you do learn it a different way, go nuts. I think I'm going to try and teach you what I think is the quickest and easiest way that you can kind of keep forever, okay? It's going to be really useful if you're doing advanced or extension maths, in fact required. You're not going to use it if you're doing standard, but we still need to do it in year 10, so stick with me. Basically, if we're going to do some graphing down the track, which we absolutely will, if we're trying to graph a circle, you get the equation by completing the square, the thing that we're about to learn. Have to, no steps about it. The other time it's really useful is if I was to factorize this quadratic equation. I know I've got factors of 8 and 1, that can't make 6. I can do 4 and 2, and I can make this -6 by doing -4, take away 2, and I would get this factorization. Now by factorizing, which is a skill we worked on last week and hopefully you're pretty confident in, what that actually tells me, which now you don't necessarily need to take it this far, but we will be later in the term, whatever is the opposite of what's written there, so if this is -4, +4 or +4 is going to be one of my x values, and the opposite of -2 is +2 is my other one. Now what that actually gives you is when you come over here to our axes, on our x-axis, so across, we are going to have one x-intercept at 2 and one x-intercept at 4, being these 2 points. You get that by factorizing. What that means is when I draw this U shape, which is the shape of a quadratic, a parabola, you might have heard of like someone's stories being parabolic, where they go like above and over the top. That's kind of where it comes from. If I was to draw that U shape, it's going to go through those 2x values. So that's why factorizing is so important, or using the quadratic formula, they do the same thing. They give you those x-intercepts. The problem is, when I draw that graph, it could look like that. It could also look like this, or it could look like this. My point being, we don't know where this turning point, we call it that because it's where it turns around, is going to be, okay? That is where completing the square becomes useful. We're going to put a quadratic, you can see I wrote it up here, into turning point form, and that's what we're going to be doing today. We're not actually going to be required to graph it, but that's the process we're doing. I think it's really important to understand that it's completely necessary down the track, and you may not memorize it, but at least if we do it now, when you get retaught it next year, you're going to be like, oh, okay, cool, I kind of remember some of that, it'll be quicker to learn. It's the whole point of doing maths. That's why we repeat over and over again. Okay, so first example here. We already know by factorizing this that it's not a perfect square, and by perfect square I mean some number is both factors. Okay, if it's a perfect square, we can write it as just that one factor squared. We've already seen some examples of that last week when we did factorizing. This isn't a perfect square, okay? Because when we factorized it, we didn't get the same thing twice. What we're going to do is we're going to kind of cheat to make it into a perfect square, okay? The way we do that is we need to write it out again, and I'm going to leave a bit of space here because I'm going to show you how to get what is this perfect factor in just a moment. And I'm going to leave this +8 here as well. Try and match it up as much as I can. In fact, I'm even going to move this over so it really lines up. Now, the trick here is to figure out what this something squared must be. It's always going to be half, so 1/2 of this middle term, or this middle number, the number in front of the x. So if it's -6, half of -6 is going to be -3. That easy, okay? It's always that way. No ifs and buts. When you do this, all I changed, I didn't touch this 8 at the end. That's really important. We're going to mention that in a minute. But all I changed is I popped this thing, I made it brackets squared, so a perfect square, and I did x and then half of this. If this was +6x, this would be a +3. If this was minus 7, this would be minus 7 on 2 or 3.5. We can do it with fractions as well. Now, the problem here is when I make this into this perfect square, let's just expand this perfect square really quickly just to prove a point. Now, when I expand it, I'm going to get, and imagine it's x minus 3, and whether you use FOIL or the table method, whatever works for you, you're going to get the same answer of x squared. Now, the funny thing about perfect squares is you're always going to get this middle term twice. Now, notice that you got 3x or minus 3x twice. So you could bring those together and get minus 6x. Notice x squared minus 6x is exactly what we had back at the start of the question. Okay, cool. That's where that comes from. That's why this is half of it. But the problem is when I finish my expanding, the last thing I have to do is these last two terms. So negative 3 times negative 3, which is positive 9. Now, I don't know about you, but I haven't seen a positive 9 anywhere. So by making it this square, I've kind of cheated because there's this 9, positive 9 in there that we haven't got. So here's the thing. And remember, we're just ignoring that. But if I choose to make this square the way I have, then I've added 9 into this. I can't do that because it's cheating. So the way you undo that, the way you fix that, is if you've added 9 in there, you need to minus 9 from the whole thing. We do that at the end. I hope that makes sense. So all we've done in terms of actual steps is we've left this thing alone. We always do, the number on its own. All we do to this x's is we're going to write it as a perfect square. So just one bracket squared, and it's going to be x. And now it's just whatever half of that middle term is. Because remember, we got two negative 3x's, which is how we end up with 6x. Now, what we need to consider is, well, what is this thing times itself? Because if I was to expand this fully, I would get this, and then negative 3 squared, or negative 3 times itself. That's our last two terms. That would give me positive 9. And if I've got positive 9 that I've added in, I need to take 9 away at the end of my equation. Now, the only thing we need to do now is tidy up. I'm going to go x minus 3 squared. And now at the end here, you'll notice I've got positive 8. That's what plus 8 means. So positive 8 minus 9. So minus 1 at the end. And you're done. This is turning point form, okay? Now, you do not need to know this yet. I'm only going to mention it very briefly. But if I was to write y equals there, and you were to do your graph, the turning point, which is, remember, where the graph like turns around, is going to be at x equals 3. Remember how we did the opposite before when it was with x? And y equals negative 1. Now, again, that doesn't need to make any sense yet, but I just wanted to show you that that's why this is so useful. That is turning point form, and you can see how easy it is to then spot the turning point of the graph. Okay, and that's done. We're going to go through a couple more examples to really consolidate this, and I'm going to show you a visual model as well, and I'm going to show you what the maths-based questions will be like. So I'll do this one a little bit quicker. Okay, so we're going to ignore the 63. We're going to go x. Now, in this perfect square, I want half of the middle term. This time it's positive, plus 63. Now the problem is, when I expand this perfect square, I'm going to have an extra, this thing squared. 12 squared is 144, and if I've added that in, I need to take it away to keep life balanced. Now all I need to do is tidy up, and I'm embarrassingly going to use a calculator because it is far too early in the morning and I am struggling. Minus 144, so minus 81 at the end. Again, if you're doing turning point, our turning point would be negative 12, negative 81. Again, I'm going to stop mentioning that. It's just useful next year. Okay, have a look at this one now. So we're going to do the same thing. We're going to pop it in this perfect square. How do you know it goes here? It's half of the middle term. In this case, it's a little bit gross. I'm just going to write it as 11 over 2. You could write it as 5.5 if you like that, or 5.5 as well is totally fine. I like to just leave things as improper fractions. I just find it easier. And don't forget that plus 10 was there. Now the problem here is, when I expand this perfect square, I'm going to end up with this thing squared as an extra piece. And by putting in that extra piece, I need to then take it away. Now, taking away 11 squared, you're going to be taking away 121 over 4, which I still don't think simplifies nicely. Okay, you could type that into a calculator, by the way. It's just squaring the top and bottom thing. Now, at the end here, we have something quite yucky this time. What are you going to do? I just go straight to my calculator and just type it in. So 10 minus 121 over 4. And you get something yuck. It can be a decimal. Why am I in laser mode? There is nothing wrong with using decimals or fractions. I got minus 20.25, which is the same thing as minus 20 1/4. However you want to write that number at the end is totally okay. Groovy. And that's kind of it. That's all you have to do. So you make a square with a half of the middle term, and you just need to take away whatever that thing that you've put there is squared. Okay? So we go half, and then because when I expand that, I'd end up with an extra square of that thing, I need to make sure I take it off. Okay, let's have a quick look at a visual model to show you what's kind of visually happening. You might get it. If so, feel free to skip through this whole visual part. You'll see all the colorful boxes, but this is for those people that are kind of going, well, blah, I need something like more concrete. So let's start with this equation here. Now what I've actually done here is I've kind of cheated, because this is really this, but I've moved that 39 across to the other side so that I can do this visual method. I've made it a bit more convenient for myself. So what I'm going to show you is this split up using rectangles. This first part here is x squared. In other words, a square where the two lengths on the side are both x. Okay, in other words, the area of that little square is going to be x times x, or x squared. Okay, and that's going to be added to a rectangle with sides 10 times x, which gives me an area of 10x. And this thing at the end is just 39, whatever it is. Okay, it just gets you 39. Maybe it's a rectangle that's 39 by 1. I don't care. Now what we do when we complete the square, remember we just ignore that last term, which is why I chucked it across the other side this time. You can do that. We always halve the middle term, okay, the x. So we always split it into 2. So if it was 10x, I'm going to cut it into 2 pieces, and now I've got 5x. Now what we try to do is we try to make a square using this x plus 5 squared. Okay, so what I try to do is I make, with these pieces, I make a perfect square, or I try to make a perfect square that would look like this by using my x squared and my 5x. Okay, and so I set it up in this little perfect square pattern. The problem is that you can see my square is quite empty, and I need to fill in this gap. In other words, I need to complete the square. That's where the saying complete the square comes from. What you'll notice is, and again we're talking area, so timesing one side by the other, that we have this missing gap. Okay, and that missing gap has side lengths of 5, notice how that is above it, and 5, notice how that is over there. So to figure out this missing area here, all I need to do is 5 times 5, which is 25. Another way of putting that is that 5 squared. Remember how when we were doing it with algebra, we said whatever that middle thing is, or half of that middle thing, because we've already split it into 2 bits, and then remember they're always going to have to add in that squared 5. Now what that looks like in our actual equation if I was to do this one with 39 on the other side, is totally fine. In fact, I might do it the normal way as well. Let's say we had x squared plus 10x minus 39, because this is the way that we've been kind of looking at it. I split the middle term into halves. So I halve it, and then I try to make this square, okay? So it looks something like this. The problem is that there's this missing part here, okay? So when I do make that square, that perfect square, I've cheated a bit because I've had to add on 25. So by adding in that 25 here, I have to make sure that I take 25 away at the end, okay? And now you would have x plus 5 squared minus 64. You can also do this in this style here, where you keep that number on the other side. That's a different method. That's more so used for solving equations, which is something we're going to do at the end of the term. So I've deliberately avoided the equals and kept it all on one side. But both methods are cool. Okay, so what I would like you to do, there's a maths-based task called completing the square. It looks pretty good, okay? Sometimes math-based can go a bit overboard. This one looks all right. I did go through it myself. You don't need to finish it. You don't need to finish any maths-based task. It's like doing every question in a textbook. It's kind of pointless after a while. Make sure you can do at least a few questions. And I'm also going to go through some examples from the maths-based task as well. So if you'd rather do them all on your own and you think you'll be fine, go for it. I'm just going to rip through these three and then we're done for today. So, and this week, in fact, the first way it's going to look, and these are ripped straight from maths-based, you might just get different numbers, is it wants us to complete this pattern, okay? Now, it might look a little bit weird at first. Basically what it's given us is this perfect square on this side, and then this empty term at the end, which, remember, in our quadratic setup, we've got a being in front of x squared, b being in front of x, and c being the constant at the end. Now I've got two gaps to fill in. What we've just talked about is how to make this into this, okay? How do I turn this into a perfect square? Remember, the trick here is, and I want to make sure that I have my answers so I don't make any dumb mistakes, is we always wrote it as, oh my goodness, what is going on? We always wrote it as a perfect square where we used half of that middle term. So x plus 10 squared. So that's what I'm going to write over here. This must be 10. Because if I was to expand that out, if I was to go x plus 10 times x plus 10, you'll notice what you're going to get is x squared, and you're going to get two lots of 10x, which is why we halve it, okay? But in other words, two lots of 10x is 20x. And when we do this completing the square, you've got to remember that we're going to end up with this number squared times itself, always with perfect squares. Usually it's just two numbers at the end, the last terms times each other, but in a perfect square, it's always that number times itself. So I'm going to have plus 100, and that's how you fill in those two gaps. We'll do one more so that makes a little bit more sense, and this one's a little bit yuckier. So we're going to do the same thing. We're going to look at this part here, which is what's important, and remember that what goes in here is always half of the number in front of x. Now in this case, it's quite gross because it's a fraction. So I need to do 1/2 of -4/3. Feel free to pop that in your calculator. When you're multiplying fractions, you're really just timesing across the top and across the bottom. So I'm going to get -4/6, which can simplify to -2/3. And you notice that they already gave you the negative there. Don't try and make that negative, you'll get a bit confused. And now it's the same step. If I was to expand this fully, I would get x squared minus 4/3x. Now, if you are expanding this fully, it's fine, good practice, but you're kind of wasting your time, because all I have to find now is, well, what's that term at the end, which is just going to be this thing squared, or this thing times itself. Again, because if I wrote it all the way out like this, and I did FOIL, or if I did the table, you'd get x squared minus Oh my goodness, what has happened? Bear with me 2 seconds. Oh, geez. Okay, so you get x squared minus 2 on 3x minus 2 on 3x, and those middle bits are going to combine to make minus 4 on 3x. And then at the end, you're going to get minus 2 on 3 times minus 2 on 3. So that's going to be positive 4 on 9. I don't believe that simplifies at all. Okay. Final one here, we're going to rewrite x squared plus 18x in this form here. Now it just gives you the form with these numbers b and c, which are just going to be numbers that you fill in. Okay, that's what b and c are. Trick here is, this is actually turning point form. Okay, and they're not going to use that notation or that wording yet, but that's what we're doing. So let's start with x squared plus 18x, and we know exactly what to do. We're going to make a perfect square where the term with x is half of the number in front of x. So half of 18 is 9. Now that's the first bit done here, but you got to be really careful, because if I was to expand this set of brackets, I've added in this thing squared. Okay, again, just to prove, and you don't need to do this proving every time once you get the idea of it, but if I was to expand that, I'd get x squared plus 18x plus 9 times 9, which is 81. You'll notice that there's no 81 in the original, so that means I've cheated by adding this 81. So I need to fix that by making it, or by taking away that 81 outside of the brackets. Now in this case, there isn't like some number here at the end, there isn't a c, so it's just going to be minus 81. If there was like a plus 15 out here, you can do minus 81 plus 15 and just group those numbers together. Okay, and that's kind of it. Again, have a crack at the maths base. You don't have to do the entire task, get some basics done, and then we'll use this heaps next year.